All right, so today we're going to compare exponential and quadratic models. So first thing, we're going to decide how to determine the type of function that's represented, okay, in each table. So I always look at my x's just to make sure that they're going up or down in the same fashion. So I see that to get from -1 to, or -2 to -1, I would add 1, add 1, add 1, add 1, add 1, add 1. So I'm going up constantly by 1 for my x values. And then my y values, if I check those, this would be like adding 0.5, and then to get from 1 to 2, I'd be adding 1, and from 2 to 4, I'd be adding 2. From 4 to 8, I would be adding 4, 8, 16. And then I just repeat this again, right? To get from 1/2 to 1, I'm adding 0.5. So my differences are not constant the first time. My second differences are not constant. So I'm going to look at this and go, okay, well, I'm going from 1 to 2 to 4. Like, it's just going up exponentially. So this would be an exponential function. And if we think about it, since we can't add or subtract the same number at any point for our first or second differences, but I do notice that I am multiplying every single time by the same ratio, right? So in other words, I've got 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Anytime that I have a common ratio among those y values, in other words, I'm multiplying by the same thing, then that makes this exponential. So we will just say that the output, which is our y values, so we'll say the y's. So the output is growing by a multiple of 2. All right, so if I look at this one, I notice that my x's are going up by 2 every time. Okay, we need for that to be a constant thing. All right, but if I look down here, I notice that to get from 2 to 0, I am adding 2. And to get from 0 to 2, I'm adding 2. To get from 2 to 8, I would add 6. 8 to 18, I would add 10. All right. 18 to 32, I would add 14. And then I've got 32 to 50, I'm adding 18. And I do need to fix something. To get from 2 to 0, we don't add 2, we would subtract 2. All right, so now I look at this and I say, okay, to get from -2 to 2, I would have to add 4. To get from 2 to 6, I would have to add 4. 6 to 10, add 4. 10 to 14, add 4. 14 to 18, add 4. So I see that these are my first differences. All right, those are not the same, but my second differences are. Okay, and if you'll recall from a previous lesson, when your first differences are the same, that would be a linear function. When your second differences are the same, that makes this quadratic. So this would be a quadratic function, and your reasoning would be, the second differences are constant. So look at number 3, I see that I'm going up 10, 20, 30, so I'm going up by 10 every time for the x's. So I look down here at my y values. To get from 15 to 12, I would have to subtract 3. From 12 to 9, I would have to subtract 3. And from 9 to 6, I would subtract 3. So I see here that my first differences are the same, so that means this is linear. And the reasoning is first differences are constant. So if you take a look at number 4, all right, from 27 to 9, I would have to subtract 18. To get from 9 to 3, I would have to subtract 6. To get from 3 to 1, I would have to subtract 2. My second differences are not going to be the same because I would have to add 12, and then I would be adding 4. All right, so I look at this and I say, okay, well maybe instead of adding or subtracting, maybe I could multiply to get to the next number. So I see that it's going down, which means I would be multiplying by a fraction. And remember, if I were to multiply or divide by like 3, that would be the same thing as multiplying by 1/3. Or if I was to divide by 2, that's the same thing as multiplying by 1/2. So all of these, if I were to take 27 and divide it by 3, I would get 9. 9 divided by 3 is 3. 3 divided by 3 is 1. So I'm actually multiplying by 1/3 every time. We always use multiplying, never dividing. So since I am multiplying by the same number every time, that makes this exponential. And you would say the output has a common ratio of 1/3. Decreases by a common ratio of 1/3. Okay? All right, now we're going to grab our graphing calculators, and it wants us to find an exponential model. So it's already telling us that we're finding an exponential model for the given data, and then we're going to use that model to make the prediction that is requested. All right, so I have the year, which is my x value, and the number of trampolines, which is my y value. Okay? So I have a bunch of data, and we've done this with quadratic models, so it makes sense that we could do this with an exponential model. So remember, if we want to put in a table of values, we're going to press the Stat button, and then we're going to choose Edit, which is option number 1. And if you have stuff in there, remember you can go over and go up and press Clear. Do not press Delete. Press Clear, and then when you pop back down, your numbers will be gone. Okay? So I've already put this data in, 1 through 7 for the L1. That's my x values. And in my second list, I've got these values over here. So you'll put those values in, and then you have to tell your calculator to do some things. So we're going to go back to Stat, but this time we want to do a calculation. So I'm going to arrow to the right to choose Calc for calculation. And I'm looking for exponential, okay? So I have linear, quadratic, cubic, quartic, all right? So I haven't quite found it, and I believe it's down here. I think it's 0. So arrow all the way down, right there. EXP reg, all right? So you're going to click 0, press Enter. So our X's are in list 1, our Y's are in list 2, so I'm just going to press Enter until I get all the way down to calculate. Press Enter. And it's going to do some diddly stuff, okay? And then it gives me the equation. So I have a number times another number raised to the x power. And they tell me those numbers are 8 point, and we'll just round to the hundredths right here. All right, 8.4, since I look behind the 5, there's a 7, so this will round up to a 6. And then the b value will be 1.4. Look behind the 1, there's an 8. That's bigger than 5, so I'm going to round this to a 2. And remember, this R2 value just tells you, remember, the closer it is to 1, the better the fit is this to an exponential graph. All right? So that makes my equation. So I'm just going to plug the 8.46 in for A and the 1.42 in for B. The X stays an X. All right? So I get Y equals 8.46, right, times, then your B, 1.42 to the X. So there's the equation that goes along with this data. Then it says predict the number of trampolines sold in the 8th year. Well, the number of trampolines is the y. So I'm literally going to take and plug in for x. It says the 8th year, so I'm going to plug an 8 in for this x. And I can just plug that into my calculator. All right, so I'm going to quit this second mode. I'm just going to plug this in. 8.46 times 1.42 to the 8th power. And I get 139.9, okay, which would be about, not quite 140, so we'll go with 139 trampolines. So 139 trampolines. Okay. Number 6. All right. This is use technology to determine whether a quadratic model or an exponential model is a better fit for the data. Okay. So let's take and go to our stat, and we're going to plug this in. All right. So we're going to have to check both quadratic and exponential. Now, if your R2 did not show up, okay, when I was talking about that a while ago on the computer screen, calculator screen, then you may have that turned off. Remember to turn it back on. You're going to press second and then 0 to pull up the catalog, and you're going to scroll all the way down until you get to diagnostics on. You'll press enter, and I think you have to press enter again, and then you should have, like on your regular calculator screen, it'll say diagnostics on, and then when you press enter, it'll say diagnostics on over here, I believe. So make sure you turn that on, or it will not give you those numbers. All right, so we're going to go to stat and edit, and then we're going to edit our values. So like I said, if you pop up and press clear, pop back down, those numbers will go away. So we have 1, 2, 3, 4, 5, 6, 7. Make sure you press enter after every one. And then I'm going to clear out list 2. And I have 4, 3, 5, 7, 11, 18, 24. All right, so let's start with a quadratic model and see how well that fits. So I'm going to go to the stat button, and I'm going to calculate. But I want to try a quadratic regression. All right, so I'm going to choose option 5. X's are in list 1, Y's are in list 2. Go to calculate. All right, so we're looking at the R2. That's what we care about. Okay, so if you look at your R2 value, you've got 0.99, and let's go back here. We'll stop at the 9 and raise that, so this will be 0.9960. Okay, so for the quadratic, R2 is 0.9960. So that's really close to 1. But remember, we want the one that's closest to 1. So we need to check the exponential. So I'm going to go back to stat, go back to calculate, but this time I'm going to choose 0, remember, because that's the exponential regression. So press 0, X's are in list 1, Y's are in list 2, go to calculate, and you're going to look at that R2 value. So the R2 here is 0.9304. Since this is less than 5, I'm going to keep this at a 4. So 0.9304. So this is for the exponential model. I get 0.9304. Which one of these is closer to 1? That would be the 0.9960. So a quadratic equation would be a better fit than the exponential. Okay? All right, the table shows the growth of a bacteria population over time. Estimate the number of bacteria after 2 hours and after 12 hours. So we have to do this twice. So first, we need to come up with an equation that would go with this data, okay? So I've got time is my x, and y is my bacteria. So I'm going to go ahead and grab the calculator. I'm going to put those in. So I go to Stat and Edit. All right, so I'm going to go ahead and clear out both my lists. All right, so for list 1, time, you have 3, 4, 5, 6, 7, 8, 9. Remember, make sure you press Enter after all of that. All right, and then for the bacteria, which is your Y, 8, 15, 30, 58, 124, 270, and 578. It's very important to make sure that your numbers are correct. All right, so I'm going to go back to Stat, and I want to calculate. All right. Now, it doesn't say what kind of calculation I'm doing. All right. It doesn't say if I should do quadratic or exponential. This is about exponential equations, this lesson is. So we're going to do an exponential. But if you were wondering, you could go and check your R2 values to see which one gives you the number that's closest to 1. So we'll do an exponential, which is option 0. So x's are in list 1, y's are in list 2. Go to calculate. So your A value is 0.86. Your B value is 2.0. We'll round that to a 5. And notice you're really close to 1 on your R2. So this is a great fit for an exponential model. So I'm going to write that equation down. So I have y equals 0.86 times 2.05 to the x. Now remember, x represents your time. So it wants to estimate the number of bacteria, so that would be your y, after 2 hours and 12 hours. So the first thing I'm going to check is the 2 hours. So I'm just going to plug in 2 for the x. All right? And then you would do the same thing for 12 hours, but instead of putting in a 2, you're going to put in a 12. Make sure that you put the dot there in the decimal. All right? So if you plug this into your calculator, just as it looks, you're going to get, now we are estimating, right? So this probably doesn't come out to be a whole number if I were guessing. So we'll put it in just to see what it comes out to be. So I have 0.86 times 2.05 to the 4th. And it looks like you get 3.6. So we'll say about 4, okay? So there's about 4 bacteria after 2 hours. And then you don't have to reinvent the wheel here, okay? Just go up and select that and then change that to a 12 instead of a 2. So after 12 hours, we're at about 4,730. Since that's a 4, we'll keep it at a 37. So a lot more bacteria after 12 hours. So 4 bacteria after 2 hours. And 4,737 bacteria after 12 hours. All right, number 8. The table shows the number of new members that join a website in different months. Estimate the number of new members in month 4 to the nearest 100. So my new members is the Y, my month is the X, and if I'm wanting to estimate, then I'm going to need a model to go with this. So I look at this and I see that I've got 1, 3, 5, 7, 9. I'm going up. But this one, it goes up, but then it starts coming back down. Okay, with exponential models, they would go like this or like this. They don't ever start to go back up. Okay, they just slowly increase or slowly decrease. Okay, so I see that in month 1 I don't have as many members, and then I jump, and then I start going back down. So this is most likely going to be a good quadratic model. So if you were unsure, though, which one, then you could always check them both. So if I go to Stat and Edit, I need to put in my new lists. All right, so I have 1, 3, 5, 7, 9. And then for list 2, I have 800, 4,000, 7,000, 7,500, and 6,500. All right, so first I'm going to look at my exponential regression. So I'm going to go to Stat, Calculate, and let's check out the R2 value for exponential. All right, if you look at this R2 value, that is not close to 1, 0.657. That right there is a big clue that you're in the wrong spot. So go back to Stat, Calculate, and this time let's do Quadratic and see what that R2 value is. So let that be a good guide for you. All right, so if I look at the R2 value, 0.9895, that's really close to 1, so this is a good fit for this data. So my A value, which is right here in front of x squared, is negative 0.94. We'll just go one after 6. My B value is 2,691.4, and my C value is a negative 1873.9. So I'm going to go ahead and write that equation. Get rid of my beautiful drawings. So if y equals negative 194.6 x to the second plus 2691.4x. And remember, these are just the numbers that came from the A, the B, and the C. And 1873.9. So if I'm wanting to check month 4, now mind you, month 4 is in between these two. Notice you're still going up, all right? So we would expect the number to be between 4,000 and 7,000. So if I'm checking month 4, that means I'm plugging in for x. So I have y equals negative 194.6 times 4 to the second plus 2691.4 times 4. I have two x values here, so make sure you plug in for both. Minus 1873.9. If you do that and you round, you have about 5,800 new members in month 4.